Hello, Mr. Wynn here with a very important video over operations with polynomials and operations with complex numbers. When I talk about operations with polynomials, I just mean add, subtract, and multiply. Some vocabulary first. A monomial is one term. It's a single number, variable, or expression that is a product of one or more variables and non-negative integer exponents, but it's a single term by itself. No plus or minus, you cannot combine. So it could be just 5 by itself, or x by itself, or 6 times y, or 2 times a to the 5th power times b to the 7th power. A polynomial has many terms, and it's an expression of 2 or more terms that cannot be combined. Some examples there is x plus 5, or 3x squared minus x plus 3, or a times b squared plus a squared times b. One more word is a degree. The degree is the highest exponent of a variable, and it cannot be negative. If there are multiple terms, pick only the highest degree, exponent. If there are multiple variables in a single term, sum up the exponents of the variables only. So 33 has a degree of 0 because it's 33 times x to the 0th power. 2x plus 5, well, x is the first power, so 2x is a degree of 1, 5 has a degree of 0, so that's degree 1. Then 3x squared, that has degree 2. So this one has a degree of 2. This one's degree of 1. It's degree of 0. Well, 2 is the highest. That's why I choose there. This one, 5 plus 2 is 7. That's why it's 7. Here, you have to add 45 plus 3 plus 2. That's 50. This one's just one thing. It's 47. 50 is bigger. That's what I mean. All right. Make sure you know your exponent rules as well. They're all there. Look at the examples. Make sure you read the thing on the side. So make sure you know if there's a number with an exponent, be sure to simplify that. So in your final answer, a regular number should never have an exponent. So they should change 3 to the 6th power into 729, 9 to the 3rd power into 729, 1 over 3 to the 5th power to 1 over 243. But the basics are when you multiply like bases, you add the exponents. When you divide like bases, subtract the exponent. You have a negative exponent, just make a fraction, flip to the other side, turns to positive. If you have a power to power is very important. You have one term inside of parentheses and an exponent outside of it, you get to multiply the exponents only. Same for power product, the same thing. It's one term inside because there's no adding and subtracting. You're allowed to multiply the outside exponent to every exponent inside. Same for power of a quotient. If it's one term, it has to be one term. So it's a single fraction inside, you're allowed to distribute the exponent to other exponents. That's it. The last one that kids forget is 0 power. Anything to 0 power is going to always be 1. Alright, so here I'm going to do some quick examples. So the first one, a to the 5th times a to the 7th, same bases. The base stays a, and I just add 5 plus 7 is 12. The second one, 5 to the 4th times 5 to the 9th. Their same bases, it stays 5. Do not say 25. And then 4 plus 9 is 13. Also, keep in mind, for the sake of time, I'm not going to fix that. You should figure out what 5 to the 13th power is. Hopefully you have a calculator. But I will not fix them. This next one, m to the 5th over m cubed. I'm dividing same basis, subtract the exponent. That's 5 minus 3 is 2. This next one, 7 to the 6th, divide 7 squared. Base is still 7. 6 minus 2 is 4. Here, this is power to the power. It's one term inside, x squared, and exponent outside, 4. So all I do is distribute this 4, multiply the 4 to every exponent inside, it's 2. So 4 times 2 is 8. That's it. This next one is also power to the power. But there's still one term inside. Be careful, there's 2 exponents here. The 3 has an invisible exponent of 1, and the p has an exponent of 4. So I have to multiply this outside 2, distribute 2 to every exponent inside. So there's going to be 3 squared p to the 8th. And technically you should change 3 squared into 9. This last one down here has a lot of exponents inside. It's still one term. This is a fraction. There's 1, 2, 3, 4, 5 exponents here. There's a 2, 4, there's an invisible 1, a 5, and another invisible 1. If I distribute 3 to everything inside there, it'll be 4, 2 times 3 is 6, x, 4 times 3 is 12, over 3, 1 times 3 is 3, y, 5 times 3 is 15, and z, 1 times 3 is 3. And you should be changing 4 to 6 to the number, 3 cubed to the number, and then reducing that if possible. Over here, I have negative exponents. I'm going to make it a fraction, move to the other side. So this will go down, become a positive. So now it's a to the positive 3 on bottom. If there's nothing on top, you just put a 1 there. Same with this. I'll move this down. So there's nothing on top, is a 1 there. It'll be 5 squared. And again, you should change 5 squared to 25. So really that's 1 over 25. Here, I'm going the other way. This, if it's on bottom, goes to the top. So it's going to be x to the 8th. Now there's something on bottom. You don't have to put over 1. You can if you want. This next one, this negative exponent has to go up. So this will be 2 squared times 8 to the 4th. And those do not combine. You have to figure out what 2 squared is. 4 times whatever 8 to the 4th is and multiply that. But you cannot say 2 times 8 is 16 to the 6th power. Alright, this one says 0 power. 5 to 0 power is 1. G to the 0 power, anything to 0 power is always 1. This next thing, 2 to the x, that quantity to the 0 power is still 1 because the whole thing's 1. You could do power to power. You could say, if you want to, let me do like this. You say 2 to the 0, x to the 0, because there's 2 invisible exponents, so 1 there, right? And 2 to the 0 is 1, x to the 0 is 1, 1 times 1 is 1. This last one, a lot of kids get confused. That 0 does not go to the 2. This is really 2 times x to the 0 power. So that's 2 times x to the 0 is 1, 2 times 1 is 2. So make sure if there's parentheses, that whole thing is to 0 power, that's all 1. But if a 0 is just next to a single letter or a single number, only turn that to 1. Alright, anyways, when adding and subtracting polynomials, determine if parentheses matters. It only matters if there's an exponent outside the parentheses, or if there's a number or negative sign in front to distribute. So we're going to simplify this, take the degree. This first parentheses does not have anything. We put an invisible 1 here and distribute that. You can. So I'll just do that. So this stays negative 5x squared. The inside is not changing for x minus 3. The second parentheses does matter because there's a positive 2 to distribute. So that's going to be positive 2x squared plus 10x plus 14. And now I can combine. The x squareds go together. Negative 5x squared plus 2x squared. They're staying the same side, so don't change the signs, but negative 5 plus 2 is negative 3 with the x squared. Then here's the x term to the first power, x to the first power. 4 plus 10 is 14 with x. Then here's the constant. Negative 3 plus 14 is positive 11. There's my answer. Then I need my degree. The degree is the highest exponent we see. Well, the x squared term is the highest, so the degree is just 2. It's the exponent. Alright, down here, the first parentheses, again, does not matter because there's no number assigned from it. It's just 1. So it stays the same. The inside does not change. The second one, I have to distribute a negative 3. So it's negative 3x squared minus 6x minus 15. I combine again. X squared, negative 1 minus 3 is negative 4x squared. Here's the x term, negative 3 minus 6 is negative 9x. Constant, 4 minus 15 is negative 11. Then the degree here is the highest exponent. The degree of each term, again, this has a degree 2, this is degree 1, this is degree 0. The highest number is 2. So the degree is 2. Alright, when multiplying parentheses, we'll distribute every term in the first parentheses, every term in the second parentheses. So if there are 2 terms in the first or each parentheses, we use an acronym called FOIL. It tells us to multiply the first terms, the outside terms, inside terms, and last terms. You get 4 things. This is pretty much double distribute. Sometimes with 3 things where you triple distribute. So simplify this. Here the parentheses matters. There's an exponent outside. I have to actually write this twice. You are not allowed to distribute the exponent because that is not one term inside. So this is parentheses. I'm going to FOIL. First, 3m times 3m. 3 times 3 is 9, m times m squared. You use your exponent rules. Then outside, 3m times 4n. That's positive 12mn. Insides, positive 4n times positive 3n makes another positive 12n, mn. And the last numbers, 4n times 4n makes positive 16n squared. So it's 4 terms, combine them. So the first thing says 9m squared, but this is mn, this is mn. They combine together to make positive 24mn. And this last thing stays the same, 16n squared. Alright, down here, this one's a little longer. There's 3 times 3 things. You can't really FOIL, but you'll triple distribute. So I'm going to do this first thing, negative x squared times all 3 of these. I'm actually getting 9 things here. So I'm going to get negative x to the 4th power. Oh, let me say the degree. This one has a degree of 2. All 3 terms have a degree of 2. So negative x to the 4th power, negative 2x to the 3rd power, negative 5x squared. Alright, then I'm going to do these next 3. I'd like this. I'm just doing negative 3x. That's negative 3x cubed minus 6x squared minus 15x. And then I'll do this one, 4 times all 3 of these. So I get positive 4x squared plus 8x plus 20. combine like terms. There's no more x to the fourth, so I'll put that first. Here's x cubed. Let me just cross it out. I'm going to cross it out. Negative x cubed. Here's x cubed. Negative 2 minus 3 is negative 5 x cubed. Here's x squared. Here's x squared. Here's another x squared. So negative 5 minus 6 is negative 11. Negative 11 plus 4 is negative 7 x squared. Then here's the x. Here's the x. Negative 15 plus 8 is negative 7x. Then the constant, there's something combined that stays the same. Here's the combined answer, and the degree here, the highest exponent I see is 4. Alright. So now we have operations complex numbers. You know the real numbers, 5, negative 2.3, 1/4, pi. There's imaginary numbers as well. Anything that has I. So far you've worked only real problems with real numbers. For example, I say some number squared, x squared is 25. Hopefully you know you square it both sides, and you get x equals plus or minus 5, because positive 5 squared times positive 5 squared is 25. Negative 5 squared times negative 5 squared is also 25. But they might give you this problem over here. Some number times itself is negative 25. Well, positive times a positive is positive. A negative times a negative is also a positive, so that doesn't work. So we get stuck. The answer to that is use I. I is called the imaginary unit. It's defined as I squared equals negative 1, or I equals squared negative 1. In the past, have you seen squared 18? It's not a nice number. You break it down to 2 times 9. You can break down a square root into multiple square roots. So really that turns to square root of 2 times square root of 9. Square root of 2 we don't know, but square root of 9 is just 3. And then we can multiply 3 times square root of 2 to get 3 root 2. That's the reduced version. But we can use the same idea for this. So I'm going to change square root of negative 25 into square root of negative 1 times 25. And I'll do like this. That equals square root of negative 1 times square root of 25. Well, I just told you square root of negative 1 is I. And square root of 25, you know, is positive 5. Or plus or minus 5, really. So this is really a plus or minus 5i. That's the answer there. Now, actually, I wanted to show you this in the calculator. So let me get that. Missed. Alright, so my calculator, if you go down to, I'm going to parentheses, I'm going to do 5i, I is second, period. So 5i squared, 5i times 5i is negative 25. If I do the other one, negative 5i second period, I squared, that's also negative 25. So we figured that out. Here's another one. I'm going to solve this a little differently. So we know that this is square root of negative 1 times square root of 48. Let's jump there. We know that this is I. Now square root of 48, hopefully I learned this method, 12 times 4. This is gone. This is 3 times 4. Here's a pair. For pairs, they go outside, and the non-pairs stay inside. So this is the front. This is I times 4 root 3. Final answer, I'll go back up here to be 4i root 3. All right, next slide. I cannot have any exponents. It says a weird rule. Memorize these 4 and now create it. Well, I to the first, invisible one's okay. Again, that's just square root of negative 1, that's I. Then by definition, I squared is negative 1. That's the main one. If you see I cubed, you use the exponent rule. So you change I cubed to I squared times I, because same basis, you add exponents. I squared turns into negative 1, and I stays I. So really, I to the third power is just negative I. And I to the fourth, we can change that to I squared times I squared, because 2 plus 2 is 4. We change each I squared into negative 1 times negative 1, it gives you positive 1. In case you don't know that, and if you get a calculator, but you probably won't, you can do second I to the fourth power, and it'll tell you that, oh, that's positive 1. And it'll tell you I squared is negative 1. And it repeats this pattern. So I to the fifth power actually is just I to the fourth power times I. I to the fourth power is positive 1 times I, which is I. I to the sixth power is I to the fourth times I squared. That's just 1 times negative 1, which is negative 1. I to the seventh is I to the fourth times I cubed, which is just 1 times I cubed is negative I. That's negative I. And I to the eighth is I to the fourth times I to the fourth, which is just 1 times 1, which is 1. Technically, you just subtract 4 until it gets to a whole number. So 26 minus 4 gets you, what's minus 20, makes it I to the 6. If I subtract 4 again, it's I squared. I squared we know is negative 1. All right, I'll stop here for now.